Hello everyone and welcome to another class of fundamentals of particle and fluid solid processing. So last week we concluded on the discussion regarding this particle size reduction, and we mentioned that we will be now looking at the particle size enlargement. Now before I go into the enlargement, let's have a quick summary of what we did on the particle size reduction. What we have seen is that different types of equipment, what is the mechanism of particle fracture, how to introduce particle fracture, what are the components or what are the properties that are dominant in dictating the fracture mechanism. Based on the fracture mechanism, we have categorized the comminution equipments. We have seen a brief overview of several equipments. During this particle breakage or the particle size reduction, the amount of energy it consumes, we have seen three different laws in chronological order, starting from the Rittinger's law, Kick's law and Bond's law. With a couple of examples, we have seen the utility of this law, that how this helps in estimating the primary guess value of the energy requirement, although this is not actually that is actual requirement for any equipment, it is much more higher than that, but to have an idea of the order of magnitude that the energy would be required to come from a certain size to a different or a smaller size range, which law would be more appropriate and why, we have discussed this as well. Based on its genesis or how it is derived, we have seen these laws applicability. We have summarized that the utility of Rittinger's law is when there is a dominant portion of surface area creation is there. For Kick's law, when we have the coarser grinding or coarser crushing, and this Rittinger's law on the contrary was used for ultrafine particles, and in the intermediate region between this ultrafine or fine particles to the coarser grinding, we see the applicability of Bond's law. So these are the things that we have covered, and we ended with the discussion on different types of equipment based on the stress mechanism that it applies on a certain particle for its size reduction to a desired ratio. Now by now we have encountered several terminologies, and couple of them are, say, like coarse grinding, fine grinding, crushing. So what are these? What typically this size range means? This size range, that term we use, the coarse grinding, when we talk about in the range of on the order of meters, say from 1 meter to 0.1 meter. This is when, so in this size range, when the particle size reduction happens, we or the industrially it is called the coarse crushing operation. When it goes below or say in the order of 0.1 meter, we say the crushing operation is happening. For finer crushing, the size range go below 1 centimeter. So when we handle the product size to a desired value of, say, 1 centimeter or nearer to that value, we call the fine crushing is required or coarse grinding is required. Below this 1 centimeter to 1 millimeter range, we say this is the intermediate grinding or the milling operation. So now I hope you are getting clear idea that why some equipments were called as crusher grinder and some equipments were called as mills, like colloid mills, and that kind of an example that we have discussed. So what happens? We have coarse grinding, then we have crushing operation, the coarse crushing, then crushing operation, Then we have coarse grinding. So, grinding is somewhat lower values of the particle or the product size than the crushing operation. Then we have intermediate grinding, that also sometimes we call as milling operation. After that we have fine grinding and ultra fine grinding. So, fine grinding goes in the range of 100 micron and ultra fine grinding goes in the range of 10 micron. So, these are the typical terminology that are used, and now as I said, you can possibly relate by the name of the equipment that in which size range it is typically used, because as I mentioned earlier that not a single equipment would give you the desired size of the product from a very coarse material. It typically goes through a stages of operation. So, at which stage which equipment is to be used, that depends on the stages of this size reduction. So, if we use crushing or grinding operation, we have the crushers, jaw crushers and all these type of equipments are there. If we go for the milling operation, or that is called the intermediate grinding in the order of millimeter or lower than that, we go for different types of milling equipments. If we go for very fine grinding or ultra fine grinding, we go to this 10 micron of the particle sizes, then that time we handle with such appropriate equipment called typically say the colloid mills. So, this summary is essential and you have to keep in mind this terminology, and I believe by looking at the equipment name you can possibly now judge that what would be the size range. And now more specifically, if we see this table say and then specifically look at the names, it would be much more clearer to you that say down to 3 millimeter of the size range we typically use this crushers or the table mills. Ball range has a wide range of applications and it can handle a wide range of particles. From 3 millimeter to 50 micron of this range, several types of ball mills, rod mills, pin mills, tube mills, vibration mills. So, all these mills are specific in nature. We have not gone through the details of such all the mills individually. It would take huge lot of time. We have gone through the overview. We have seen one example in all of the cases which would serve the purpose of having an idea, overall idea that how this is used or what kind of stress mechanism it provides for the size reduction. So, again when we go say near about 50 micron or lesser than that, we can still use ball mills. As I mentioned, it has it can handle a wide range of particle sizes. We can use vibration mills. We discussed this while discussing the ball mills. There can be sand mills, colloid mills, fluid energy mills. These are the ultra fine grinding equipments. So, that means what we have seen the equipments based on the applied stressing mechanism or applied stress, how it is provided to the particle. Based on that, we have seen several categories. We have seen 3 categories, that is the impact plus attrition, the compaction, and that is the crushing plus attrition, and the combination of all these mechanisms. And today we have seen that based on the desired level of size reduction, what are the types of equipment or which specific equipment we can use. So, this selection of comminution equipments obviously depends on certain parameters, and one of them is the material property. We have seen the earlier points as well, that how the stress can be applied or what kind of fracture we need to provide. That is one of the strategy, that is for sure. But along with that, material properties plays an important role in deciding the type of equipment that we will be using. So, what kind of material properties? Definitely one of the property is the hardness, which is the resistance to abrasion. Hard materials are quite and logically difficult to break. Abrasiveness, which is closely related to the hardness and is an important factor. Very abrasive materials can be handled at a low speed operation, for example in ball mills, because these are the abrasive in nature, their abrasiveness is very high. In such cases, it is desirable to handle those materials where the RPM or the rotation or say the operations are having low speed. So, as the example here it is mentioned the ball mills, we can see that ball mills operate at a very low speed, the low speed of rotation. So, in that scenario such material can be handled in these mills. Now, toughness is another important parameter for the material properties. It is the resistance that it provides in order to resist a crack or its propagation. So, the tougher the materials, it becomes something similar to the hardness, that it is difficult, it becomes difficult to break, and toughness is opposite of the brittleness. So, these materials actually exhibits plastic deformation than the propagation of new cracks. So, the control on this size reductions is difficult on the tougher materials, and sometimes if we can reduce the temperature while operating or while treating or processing these materials, it can render some brittleness, which helps in terms of energy consumption. If the material is in fibrous in nature, then it can be comminuted in shredder or cutters, not in usual grinders or crushers. So, because it has the fibrous nature, if the material exhibits cohesiveness or adhesivity, cohesiveness is the attraction with the same type of particles, adhesion is the different types of surface, say the equipment surface and the particles. So, the moisture content, particle size, this basically dictates these properties. So, in such cases when there is this cohesive or the adhesive property, it is actually difficult, it makes the particles or the feed for its flowability becomes very less. So, the discharge or say the feed inlet, all these things becomes a difficult scenario while handling these materials. So, a wet grinding in such cases or handling these cohesive or the adhesive materials becomes immensely helpful while having its size reduction. So, that means we have to look into the equipments which can be operated in wet grinding scenarios as well. We have seen the ball mill can handle dry operation as well as the wet operation, it can be carried out inside a ball mill. So, similar type of equipment or the equipment or the crusher or the grinder that can be operated in wet condition, or there is a flow of continuous fluid, particularly liquid, in such scenario the equipment should be efficiently working. That kind of equipment we have to choose. It has been seen that this removal of generated heat by cold air, if we reduce the melting points, then it becomes energy efficient to have the size reductions of that particular material. Other different properties that are important sometimes is that if the process is thermally sensitive for the materials, then in presence of inert atmosphere or the inert carrier medium, that grinding operation can be carried out, because the material is itself a temperature sensitive material. So, in presence of atmospheric air or say the oxygen, it can create some hazard. Similarly, if we have to process toxic or say radioactive material, then we have to choose a suitable carrier medium so that it doesn't react or doesn't explode or doesn't create any other nuisance, and it should be operated in a closed circuit, that means in a closed loop, which we will see in the next slide, that what are the different mechanisms to handle this set of operation. And as I mentioned, we cannot neglect the importance of the carrier medium apart from the material properties. So, this carrier medium during this feed inlet or the discharge, typically that these are carried in presence of gas or liquid phase, but again we have to look into the aspect of the surface property of the particles, whether it is soluble in liquid or its size changes by mixing it in the liquid. Then you have to use the gas phase, what its activity or the reactivity with a certain gas phase. If that is sensitive to the gas phase, we have to use liquid phase. So, such kind of parameters we have to decide, or we have to think in deciding this use of appropriate size reducing equipment. We have to also think of the forces to the particle while it flows with the carrier medium. We have to account for the friction and abrasion while it flows, because we will see during its transport in fluidic media, the solid particles create a lot of friction and the abrasion. It totally changes the hydrodynamics of the flow. Moreover, whether the velocity or say the influence of carrier media on the crack formation, is it makes the solids more brittle or more tougher. The presence of the carrier media, in presence of the carrier media, if the solid particles becomes more brittle or more tougher, depending on that scenario, we have to choose the size reducing equipment. And whether it alters the cohesivity or the adhesivity of the material, that we have discussed, that this carrier medium is typically used in order to increase the flowability of the solid particles. So, this has to be kept in mind. All these parameters are to be considered while selecting appropriate size reducing equipment or the comminution equipment. And these equipments just not only work standalone in certain cases, or in most of the industries these are not just a standalone operation or the standalone equipment. It is followed by some other operations. For example, after size reduction, drying can happen in drying industries. While it makes some cake or say soap and all this stuff, so this has to be dried. This is one of the operation. This size, after reducing it may be compacted or may be densified. So, such operations are typically followed happens after this size reductions process. So, typically how these instruments are used, it can be operated in open circuit or closed circuit manner. Open circuit means open loop, where only one pass happens through the mill. That means the feed comes in, goes inside and leaves the mill after the crushing or grinding happens. This is the one time pass of that, and then this product is used for further operations. Now, in this case, the only controllable variable is the residence time. So, and this residence time is important. We have seen in our previous discussion that how retention of the solid particles in the milling unit or the grinding unit for a longer time, how it can help in reducing the size. And since there is no feedback or recycle of this product, the efficiency or say effective operation of the milling operations completely depends on the control of the feed rate. The way you provide the feed rate, it dictates the residence time, and which in turn dictates the product size variation or the product size distribution. In case of closed circuit operation, the materials leaves the milling operation or the grinding operation, and then it is separated according to the particle size, and oversized particles again fed back to the inlet along with the fresh feed. So, it is a kind of a closed loop scenario. In this case, the mean product size and the size distribution can be better controlled than the open circuit operation. So, here what happens? The feed comes in, it goes to the mill, the product is separated in a separator or a classifier, where we receive the final product, which is the finer particles, and if those are not suitable, the bigger size particle or the oversized particle again fed back, which mixes with the feed and goes into the operation. So, it continues until and unless we have the sufficiently finer product. So, in this case, that means you create the products of certain desired range. This is more controllable than the previous open circuit operation. Closed circuit operation is most popular in the industry because it is efficient. You control the mean product size as well as the size range, but in certain cases you cannot avoid instead of using this open circuit operations. So, the other operations that we mentioned can be of dry or the wet. So, dry milling in absence of any water, most popular liquid phase in the wet operation is the water. So, here what happens in dry milling, either air or some other gaseous carrier medium is used. It takes the feed to the mill, okay. It is then grinded in the milling or crusher, then it goes to the classifier, where in the classifier again we have the oversized material that comes and mixes with the feed once again, and the finer products or the desired size or the let us say smaller products again are classified in gas cyclone, where we get the desired product. So, this is the kind of closed loop or the closed circuit operation that happens, where we have this mills followed by a closed loop of classifier and the subsequent classification of the finer products. Now, in this case, this is the dry milling operation, which means the carrier medium is air without humidity, dry air. In case of wet milling, and again closed circuit operation, because as I mentioned, closed circuit operation is more popular because of its efficiency. So, what happens here? Here we have water and feed, that this water carries the feed, goes into the mills, and then we have a certain desired product, which is further the fresh water is added here. This goes for the classification in hydrocyclone, where the finer particles are collected at the top and the bigger particles again comes back to the mill with the fresh feed, where water is supplied everywhere in order to facilitate the flowability of the material. So that means this dry milling and wet milling, and how this closed circuit operation works, how the open loop works or the open circuit operation works, we have seen these variations, and this sums up this whole size reduction summary that I wanted to convey, that starting from the size reduction of the particle, knowing the stress mechanism, categorization of the equipment based on the stressing mechanism, the energy consumption, the selection of the equipment based on the different stages of crushing, grinding or milling operation, how the material properties influences the choice of comminution equipment, how this system works in an industry in a very sketchy way, that it can be operated in open loop or open circuit operation or closed loop or closed circuit operation. In open loop cases, you have control only on the residence time, that is the feed rate which controls the residence time, and this in turn results in the size variation of the product. But in closed circuit operation, the oversized products always goes back to the loop and mixes with the feed, fresh feed. So you have a better control on the feed size, the mean size of the product and the size distribution of the product, as well as this closed loop operation we have seen in terms of wet milling and the dry milling operation. In wet case, we have water as the carrier medium. In dry milling case, we have dry air as the carrier medium. Both has its pros and cons. Based on this, we have to choose a appropriate size reducing equipment. So with this, I conclude today's talk, and from next day we will start the discussion on the size enlargement part. So this is the overview of size reducing equipment. Although the all equipments that I have mentioned, the names are not covered in details, but those are interested can look into the different handbooks, say Perry's handbook or Woolman's encyclopedia, regarding these details of this size reducing equipment and its design. With this, I thank you for your attention, and we will see you in the next class.